Hello dear viewers, this is I, voice, Gary, speaking to you as Buddy from Town's narrator. Since Buddy began his exploration of the cosmos, he has become interested in current news about the early universe. After reading the article, Uncovering the Mystery of Early Massive Galaxies Running on Empty, by Amy C. Oliver of the National Radio Astronomy Observatory, Buddy from Town has learned about a half-dozen early massive galaxies that ran out of fuel. In her article, Amy C. Oliver says, the early massive galaxies, those that formed in the 3 billion years following the Big Bang, should have contained large amounts of cold hydrogen gas, which is the fuel required to make stars. But, Oliver explains, scientists observing the early universe with the Atacama Large Millimeter-Submillimeter Array, ALMA, and the Hubble Space Telescope, have discovered that the cessation of star formation in the 6 target galaxies was not caused by a sudden inefficiency in the conversion of cold gas to stars. Instead, it was the result of the depletion or removal of the gas reservoirs in the galaxies. The 6 high-redshift galaxies that were selected for observation from the Requiem survey are known as Quench Galaxies, or galaxies that have shut down star formation. Note: galaxies at high redshift are very distant galaxies, and since light propagates through space at a finite speed of approximately 300,000 km per second, they appear to an observer on the Earth as they were in a very remote past, when the light departed them, carrying information on their properties at that time. Observations of objects with very high redshifts play a central role in cosmology because they provide insight into the epochs and the mechanisms of galaxy formation. If one can reach redshifts that are high enough to correspond to the cosmic epochs when galaxies were forming their first populations of stars, and began to shine light throughout space. The purpose of Requiem is to use strong gravitational lensing as a natural telescope to observe dormant galaxies with higher spatial resolution, which is why the team made use of the 2 telescopes, Hubble and ALMA. This enabled the scientists to get a clear view of galaxies' internal workings. Note: gravitational lensing is caused by a massive body between a distant object and ourselves. It can create the appearance of 2 or more objects where there is really only one. The massive body, such as a galaxy or black hole, creates a very strong gravitational field in space. The team of scientists discovered that the data revealed through the study is inconsistent with what astronomers expect of the early universe. The scientists observed the selected galaxies using Hubble to better understand how the galaxies formed and died, which revealed details about the stars residing in the galaxies. Simultaneous observations with ALMA revealed the galaxy's continuum emission, a tracer of dust, at millimeter wavelengths. This allowed the team to ascertain the amount of gas in the galaxies. In Amy C. Oliver's article, Kate Whitaker, lead author on the study, and assistant professor of astronomy at the University of Massachusetts, Amherst, explains that the most massive galaxies in the universe lived fast and furious, creating their stars in a remarkably short amount of time. At these early times, there should be an abundance of gas fueling star formation. Whitaker says they originally believed that these quenched galaxies hit the brakes just a few billion years after the Big Bang. However, in their new research, the scientists concluded that early galaxies didn't actually put the brakes on, but rather, they were running on empty. Christina Williams, an astronomer at the University of Arizona and co-author on the research, explains in Oliver's article that the scientists don't yet understand why this happens, but possible explanations include, either the primary gas supply fueling the galaxy is cut off, or, perhaps a supermassive black hole is injecting energy that keeps the gas in the galaxy hot. This means that the galaxies are unable to restart the engine on star production. Whitaker says that these are the first measurements of the cold dust continuum of distant dormant galaxies, and in fact, the first measurements of this kind outside the local universe. Note: because of their extreme distances, galaxies at high redshift necessarily appear to an observer as faint objects, even if their absolute luminosity is large. However, only a very small fraction of all the faint galaxies observed in a deep image of the sky are located at high redshifts. This is because galaxies have absolute luminosities that cover a wide range, extending over several orders of magnitude, and fainter galaxies are also much more abundant in space than brighter ones. As a result, Deep images of the sky are crowded by a myriad of relatively close but intrinsically faint galaxies, while intrinsically luminous galaxies at high redshift are comparatively very rare. The new study has allowed scientists to see how much gas individual dead galaxies contain. Whitaker explains, they were able to probe the fuel of star formation in these early massive galaxies, deep enough to take the first measurements of the gas tank reading, which provides a critically missing viewpoint of the cold gas properties of these galaxies. In the article, Kate Whitaker says, the mere fact that these massive beasts of the cosmos formed 100 billion stars within about a billion years, and then suddenly shut down their star formation, is a mystery we would all love to solve, and Requiem has provided the first clue. The results of the research are published in Nature. If you would like to follow along to see Buddy from Town become Buddy of Singularity, please click subscribe and a like would be appreciated. Until next time, dear viewers, keep looking up and looking back, way back.